Hello, welcome to my channel Medico Medical. Today we are going to discuss about osmotic fragility test. The topics we are going to discuss about is definition of osmotic fragility, principle, specimen, procedure and observation. Let's know about osmotic fragility. What is osmotic fragility? It is a test to measure the red blood cells. This test is performed to detect thalassemia, hereditary spherocytosis, anemias like autoimmune hemolytic anemia. Let's know about hereditary spherocytosis. It is a common disorder which red blood cells are defective because of their round ball-like shape. Look at the picture. The normal RBCs are biconcave in shape, but the hereditary spherocytosis is round in shape. Hemolytic anemia. It is increased hemolytic fragility. Look at the picture, you will come to an idea. Thalassemia is an inherited condition that affects the portion of blood which carries the oxygen, that is hemoglobin. The thalassemic RBCs are microcytic and hypochromic in nature. Sickle cell anemia also have decreased osmotic fragility. Let's know about principle of osmotic fragility. The small volumes of blood are mixed with a large excess of buffer saline solution for varying the concentration. The fraction of the red cells lysed at each saline concentration is determined calorimetrically. The test is normally carried out at room temperature for 15 to 25 degrees Celsius. The resistance which erythrocytes offer to the hemolytic actions of hypotonic saline is used as an index of the osmotic fragility of RBCs. The specimen required is 5 ml of whole blood. It should be collected in sodium heparin tube or lithium heparin tube. But note it, hemolyte sample should not be used. It must and should be rejected. Let's go through procedure. First, place the 14 tubes on the wooden rack and label serially from 1.00% to 0.00%. Fill the tubes up to 3/4 of the sodium chloride solutions. Add 50 microns of whole blood to every tube. Let the tubes be at room temperature for 30 minutes. Mix well by using the vortex. Centrifuge for 5 minutes at 2500 rpm. Carefully transfer the supernants to the cuvette. Set the optical density to 0 using supernant in test tube number 1, which represents blank, or 0% hemolyze test tube number 14 represents 100% hemolysis. Estimate using a spectrophotometer at a wavelength setting of 540 nanometer or photoelectric calorimeter provided with a yellow-green filter. The calculation is percentage of hemolysis is equals to absorbance of tube divided by absorbance of 14th tube into 100. Observation: in tubes, the solutions of higher concentration, blood settles down with a clear colorless supernant. As the concentration decreases gradually, the supernant starts getting a reddish tint. The reddish tinge is first seen indicates the beginning of hemolysis. The solution in which hemolysis is complete, all RBCs are lysed uniformly red, clear and transparent without any sediment. Thank you for watching. I hope you all have understood. Like, share and subscribe.